Here is a video I made about 4 years ago. Technology has changed a lot since then. So I'm going to go ahead and update it with some of the software and new technology. So let's go ahead and get started with the building foundation. And if it is going to be a garage, make sure that it is sloping from one side to the other so that any water will flow out of it, or snow that eventually turns into water. And for a garage, a slope between 1/8 of an inch and 1/4 of an inch is usually sufficient. And you can see here where we have about 2 inches. The stem walls are level and the garage floor is sloping. So you can see where it kind of comes down here and gets a little bigger, telling us that there is a slope in the floor. So there we have the floor. Let's go ahead and put our first wall in. Take a look at that. And you can see where we have a couple of breaks here in the lumber. And for the top plates, the breaks cannot be smaller than 4 foot. Or should I say, the lumber that we're using for them cannot be shorter than 4 foot for the horizontal top plates. Otherwise, you might need to strap them. And that won't be the case on the bottom, but you will need to put some anchor bolts in. And you can see here where we have anchor bolts within 12 inches of the break on each side of it. And that 12 inches usually refers to any break, any point, even the corners, where there is a separation in the sill plates. And the corners of the walls will overlap so that you can attach them firmly together. And we are going to have a couple of support boards here for our floor framing. And I went ahead and made this garage 24 feet long, 20 foot wide. And the reason for that is we're going to put the stairway in the back and you'll still have room to park a car in here. Or should I say you will have 20 foot space to park your car in. Next up, let's go ahead and throw the floor framing in there. These will be 2x12 joists for this project. However, there is no guarantee that that will work on your project. So keep in mind that I'm only providing you with examples of how this can be built. However, the lumber sizes might be a little different on your project. And we are going to use 2x12 hangers along with some lag screws. And you might need to use between 2 and 4 lag screws to connect the ledger to the wall framing stud. And again, I will not be able to provide you with the sizes of those lag screws. However, I would think that something about 3/8 of an inch in diameter and about 4.5 inches long should do the trick. Next up, take a look at how I have offset the joists so that they are not going to be in the way of the lag screws. And if you lay out all the studs 16 inches on center and the joist 16 inches on center, then you shouldn't have a problem with that. Just work it, go all the way down. And if you come to a spot where the doubler might be in the way, then you might need to relocate some of the wall framing studs. Next up, let's go ahead and take a look at how we built this little area here. And we do have the doubler sitting on top of a couple of framing studs and connecting to the doubler on the other side with a double hanger. And we're basically going to do the same thing on the other side, except the joist here will be a little bit longer, and that will become obvious here in a few seconds as we install our stairway. And you can see that the top section is going to be a little bit longer, making this section of the floor and this section over here about the same size in length. And we are going to use 4 stringers, cut those out of 2x12. And they will connect to the floor with pressure treated lumber that we can use some type of shots and pins or other framing anchors to securely connect the stairs to the concrete foundation. And if you look over here, you will see that this stringer is going to be sitting on top of the stem wall. However, you could always move the stairway over a little bit if you don't want this. And I really don't have a problem with this because you're just going to have a little bit of a notch in the lower riser. And it's going to be in a section where no one's ever going to step. But again, you might need to approve something like that with your local building department. And we are going to nail a 3/4 inch spacer board here for our drywall. And that will provide us with a nice slot to drop the drywall into so that we don't need to notch around every single step. And of course, we are going to need fire blocks for the stairway. Next up, let's go ahead and go to the top of the stairway. where we can see how the stair stringers connect to our floor framing. And remember, this section here will actually be part of our upper floor, and the last riser will be right here. And I didn't leave a gap between the stringer and the doubler here because we're only going to have a small section of the stairway that we would need to notch our drywall around, if at all we are going to install drywall on this part of the floor. So keep in mind that even though I'm providing you with information for drywalling the garage, you can eliminate some of this stuff and even redesign some of it if you're not going to drywall anything. Next up, let's install our risers, and we are going to use 3/4 inch plywood or OSB for both the risers and the treads. Next up, let's go ahead and get a side view of the stairway. And remember, if you do have a longer vehicle, then something like this might work out because you're going to have 24 feet on one side of the garage, and then you'd be able to park a smaller car on this side of the garage where the stairway would be in the way of that. Another view of it there with our 1-inch overhang or nosing. And you can see here where this notch isn't really going to be a big deal. And remember, the garage floor is going to be sloping, so we are going to have a slight variation in the lower height of the riser, and you might need to locate the desired height of the riser in the center. For example, this stairway, I believe, has a 7.4 rise. And if you can, try to locate the 7.4 rise, the total overall height of the riser in the center where most people are going to be walking. Next up, let's go ahead and take a look at the floor sheathing. And for our project, we are going to use 3/4 inch plywood or OSB. And something else I want you to take a look at will be this piece of floor sheathing that I needed to move 1/4 inch so that I could get my 1-inch nosing here. And this would be something that you're going to need to think about when designing your stairway to make sure that you have enough room up here for a landing, usually 36 inches by 36 inches. And to fix something like this, all I needed to do was move it 1/4 inch forward, providing a gap here of 1/4 inch that is not going to be a big deal. And I say that, but to some of you perfectionists out there, it could be. And if that's the case, then make sure you locate the stairway to where it will not create a problem. Next up, let's go ahead and install our fire blocks for the floor. And you could always install these while you're framing the walls. However, sometimes that's difficult to do. And if that's the case, wait till you finish the floor and then go ahead and install the blocks. Sometimes that makes it a little easier. And again, the 2x4 provides us with a 1-hour burn-through fire rating. And our fire blocks are used to prevent a fire from pulling oxygen from the floor above or allowing the flames to enter into the wall cavity and then start working its way into the upper floor. And I'm a firm believer in the fire blocks. It really makes a lot of sense. As you're coming down the stairs from above, you don't want flames to be coming through the wall cavity while you're trying to get out of the building that's on fire. Next up, let's go ahead and take a look at the roof rafters. I am using 2x10, and we will need to notch the gable end rafters for our lookouts, or the supports that we will be using to support our fascia board on the gable end. And if you've watched enough of my videos, you know that I like to see the shaped blocks so that we can get some perimeter nailing or diaphragm nailing for the roof sheathing to help it connect to the wall framing a little easier. And you could always install more building hardware, and I will be going over the building hardware in future videos, along with some of the problems I find along the way, or even you as a viewer might find. And you can leave that information in the comment box or email it to me. Next up, let's take a look at this seat cut. And a seat cut like this could create problems for nailing shear panel. And if that's the case, then install the shear panel first and then the roof rafters. Otherwise, you will be notching around the roof rafters. Next up, let's go ahead and install our gable studs, 16 inches on center. And all of the walls here are 2x4. You can always make them 2x6 or 2x8, especially if you're looking for a little more insulation or structural support. And I went ahead and installed a 2x4 here for ceiling backing to attach our drywall to. And something like this provides us with a little more nailing for our gable studs. So we would have a couple of nails going through the gable stud into this board and this board, and then a couple of more nails going from the rafter into this backing board. And again, if you need a little more information on that, let me know. A view of our lookouts and how they are notched into the last rafter there. And our overhang on this project is 16 inches. And since it's a straight gable roof, there's really not a lot to this, because if everything is done correctly, then all of your rafters should be the same size along with your collar ties. And don't forget that the one on the end might need to be shaped, especially if you are going to drywall the ceiling. And remember, our collar ties will help with any type of uplift. And if you're looking for more information, go to the website, click on the Home Building tab, and then click on the framing link, and that will take you to another page where you will find a roof framing link that will have all of the roof framing videos. Next up, we have another view of the gable end. Next up, let's go to the other side. Another view of that. Come down to the front where we can see the garage door, or at least the garage door opening, I should say. View of the roof sheathing. And of course, now for the grand finale, the biggest problem that I have seen people run into while doing projects like this, and that's going to usually have something to do with a headroom problem over here. And trust me, I have seen this mistake made over and over again. And in this example here, we have about 6 feet from here to here, and that's not going to leave us enough headroom according to most building codes. Now, what I did here was took an area that would represent the width and the length and the height of the amount of room necessary to make something like this more acceptable to your local building department. And just like that, the 2-car garage is officially done. But really, the game changer here is the loft. By adding these stairs instead of a pull-down ladder, this space up here becomes an actual room. And in the second half of the video, I wanted to mention a problem that rarely gets talked about. And that will be to either use feet or inches on the entire project for any measurement a fellow construction worker will be using. And I would strongly suggest using inches because that's what everybody uses that I ever worked with. And this includes everybody: plumbers, electricians, heating and air conditioning contractors, along with framing carpenters. And in this example here, the layout for a door opening is going to have a 35-inch 2x4. It's right here. You can barely see the 35 right there. And something that will provide us with a good example of why you might not want to use a pencil. And of course, they're covering up. There's a little slash here, 6 1/4 wall framing studs over the door header. Here's another measurement where we have one top plate and then a 66 1/4 inch header with 2 subsills and 31 1/4 inch wall framing studs will be used in between the bottom framing plate and the windowsill. And this is where it can get confusing. If I'm using feet on some of my measurements and inches on the other measurements, then I might think this is a 6 feet 0 inches. But it's not, because everything's in inches and won't be confusing. Another thing I would suggest would be to write all of your measurements clearly. Even though this is upside down, you can see here where this looks like a 73, but it's actually a 75. And you can use lumber crayons or felt tip markers. And I know a lot of people like to use permanent markers in case there are any problems in the future. They can just simply grab a broom, clear off the area, and then look at the measurements to see if these people made a mistake or someone else did. So what we're looking at here is the 22 1/4 inch cripples over the door header, along with a 33 inch long 2x4. So 33 inches, 21 1/4. And in our next example, you might not be able to see this very well, but somebody went ahead and wrote 24 by 60 RO. We have a 24 inch by 60 rough opening for what appears to be a window. And of course, this could be a problem if I was using feet and inches. Is this a 2 foot 4 inch wide window by 6 foot? 6 foot 0 inches? No, it's not, because we wrote everything in inches. And no, I'm not about to suggest everyone is going to do this, but I can tell you the job's going to go a lot smoother if everybody does do it. And thanks for watching. If you enjoyed the video, let us know by hitting the thumbs up button or letting us know in the comment area.